Hi everyone, welcome to our March student body meeting. We're going to get started. Before we do, just make sure, as always, to rename yourself in Zoom. Make sure that we can see your first name, your last name, and your grade level. So today we're going to do something a little bit different. We're going to start with our speaker presentation, and John V will be introducing our speaker today.
So today we're having a senior engineer from Qualcomm. His name is Mr. Manoj, and he will be speaking to us about software engineering.
Thank you, Janvi. Shall I get started?
Yes, you can start sharing your screen and beginning your presentation.
All right. Hey, everybody. Good afternoon. Thanks for joining. My name is Manoj, and I'm a senior software engineer at Qualcomm. I live here in San Diego, California. Wanted to give you guys a brief into what a computer engineer, software engineer does. Little similarities to what an electrical engineer does, and how is it different from a computer science engineer who does pure software. So let's see what we have for you today. Agenda, a little bit about me, my background, intro to electrical and computer engineering, deep dive into what computer engineering is, what my role as a Linux software engineer at Qualcomm entails, and some activities that I know some of my friends who went to high school in the US did, and we can take question and answers after that. A little bit about me. So I'm originally from India. I was born there. I studied my undergrad at the University of Mumbai, graduated 2013 with a bachelor's in electrical engineering. I did my master's at the Missouri University of Science and Tech in computer engineering, graduated 2015. I used to live in Sugar Land and worked at Texas Instruments as a embedded software engineer for 5 years. And then as recently as 2020, I moved to California to work at Qualcomm as an embedded Linux software engineer. So I wanted to give you guys a background as to how I got here in terms of my background in electrical engineering as a bachelor's degree and master's in computer engineering. And then now I do software, which is embedded software development, and how that relates to computer engineering. So moving on, this is a high-level introduction to electrical and computer engineering. I'm sure as you are all part of the engineering academy, you have a pretty overview or probably a deeper understanding of electrical and computer engineering. I just wanted to give you my perspective to it and see if it adds value to your understanding. So I'm sure a lot of you can or may recognize this. If you can take a moment and maybe type it out or something, how many of you can recognize what this is? Just like a simple answer could help. But this is something all of us have in many forms. And I know you have question and answers at the end, but you feel free to type it out, and no prizes for the best answer. But this is a iPhone XS printed circuit board. This is part of all, a similar printed circuit board is part of all our phones, whether it's iPhone or an Android phone or any other phone. And all of this is possible thanks to a lot of computer engineering and software engineering that I'm going to talk about. So our cell phone is going to be an example that I'm going to refer to quite a few times. It's going to be the common theme across. And as an embedded software engineer, I work on a lot of these things. So I'll try to, walk you through all those facets of computer and electrical engineering. So the layers of the ECE world. This diagram I'm trying to explain from the lowest level how it looks. So if you look at the lowest level where physics is, this is probably a lot of things that you as students are learning about electromagnetism and electrons and magnetism. So at the EE level, we're talking about very close to physics. So the devices that are built based on the principles of physics, and circuits that are built with these devices. Building on top of these circuits is the processors. Like think about a computer microprocessor. Um, a microprocessor is the foundation of a printed circuit board that we just saw on the previous slide. And that microprocessor runs something called as a system software. Now, system or operating system software is what differentiates an Apple phone versus an Android phone. Most of you may know that an Apple phone runs iOS versus an Android phone runs the Android operating system. And that layer of understanding electronics and system software is what computer engineering entails. What happens on top of computer engineering is computer science. Think of the applications you use, a Facebook, an Instagram app, or a Snapchat, or any of those apps that we have on our smartphones. They're all built by computer science engineers. And although they don't need to know the physics of the devices, they do understand what happens at the computer engineering level, and then they build their apps on top of it. So this here is computer science, the highest level. You use Java programming, Python programming. Probably many of you may have done this in your high school projects, use all these high-level programming languages. At computer engineering level, we're talking about hardware architecture, and we talk about C programming, which is low-level embedded programming, very close to the chip. And at the bottom layer, we have the physics. So this is the hierarchy of the ECE world. I wanted to quickly show you guys a video on how a microchip is fabricated from sand. Just take a quick look. This should probably be a minute and a half.
Sand is the raw material for silicon-based chips. To make silicon wafers, a huge monocrystal is drawn from purified silicon melt. This ingot is cut into slices. This is a silicon wafer. The silicon wafer is polished. Then it is spin-coated with a photosensitive resist. Light transfers the circuit structures depicted on a mask through Zeiss optics to the wafer. The light changes the chemistry of the photoresist. The exposed parts of the photoresists are soluble and are removed by a developer. Etching forms the resist structure on the wafer. Further processing steps are, for example, the application of barrier layers and copper filling to provide the wiring between transistors. The surface is planarized by polishing. Similar processes are repeated to create the full three-dimensional chip structure. After many steps, the wafer is fully printed with all identical chips. These chips are cut out from the wafer. The last production step is the packaging of the chips. Microchips are part of electronic devices and are crucial for trends like virtual reality and artificial intelligence.
So as you saw in the previous video, how sand comes up to life and becomes a microchip. That was just to give you a taste of how engineering happens across different layers, and we get to the final product, which is a microchip that's probably pervasive in all our parts of our life. We're able to do this video chat or Zoom meeting thanks to a lot of semiconductors and electronics that's running in our laptops or cell phones. To take a little bit of a detour and enter into computer engineering. Computer engineering is a branch of electrical and computer engineering that integrates computer science and electronics engineering. And this is required to develop computer hardware and software. So at my job, I'm not just dealing with software abstractly. I'm trying to solve problems with the help of hardware and find suitable hardware that'll help solve these problems. So that's computer engineering as a broad definition. Uh, the fields that computer engineering involves is broadly categorized into two: computer hardware engineering and computer software engineering. These are not definitions particularly found out there, but I just chose to break them down into these to simplify our understanding. But uh, hardware engineering can involve processor design, like designing a microprocessor. Um, VLSI engineering, VLSI stands for very large scale integration. So making those microchips micro is VLSI. Embedded systems design. Think of an example of embedded systems being your cell phones or your smart refrigerators or your smart washing machines. All these smart, your Alexas in your Google Home, all of these are embedded systems. They have a particular embedded task, that is, they deliver certain information or deliver certain end goal. It's not a general purpose computer like your laptops or your desktops. So they have a particular purpose, that there's an embedded objective, and that's why we call them embedded systems. And computer communications and wireless designs, your 4G to 5G transition, having hardware that will support communication at higher data rates and so on. So that all this encompasses computer hardware engineering. Software engineering consists of low-level compilers and operating systems. So we have an Android operating system, an Apple operating system, Microsoft has Windows. All these operating systems, to work on a particular hardware, needs a lot of optimization and needs a lot of specific engineering. That's where computer engineers come in and develop software that sits on a particular hardware. So if somebody is developing software that is agnostic of hardware, they're called computer science engineer, and they delve at a different level. They don't really worry about the low-level hardware. Um, it also involves coding, cryptography, and information protection. Think of it of your password protection to your files, password protection to access your machines. All these come under computer software engineering. There's a lot of hardware component involved, which we don't see as end users. When we just type in our password, we don't realize that there's a lot of hardware magic going on behind the scenes as well. Computer vision and robotics, a very, very important area which is evolving. All the autonomous driving that we're seeing around us, the Google car, the Teslas, all of them have significant amount of computer hardware and software that enables these functions. And finally, signal and image processing. This is your speech recognition systems in your Alexas and Google Homes, your OK Google responses and your Hey Siri commands to your phones. All this is signal processing. Image processing, there's the world out there for using Instagram filters and Snapchat filters. All that is image processing, and the quality of pictures that you probably took when you were kids versus now when you're becoming young adults. You see the cameras have evolved so much. All this is thanks to computer software engineering and image processing. Uh, there's a lot of future research that's going on out here, and by the time you come to college or you're still interested in pursuing a career in computer engineering, you'll see that these are some of the areas where there'll be a lot of emphasis going forward. Quantum computing, speech recognition, virtual and augmented reality, and autonomous systems research. All of these are already prevalent in some form, and people are actively doing research, but it's not yet come to the forefront of where it should be. I mean, speech recognition for now, we can say that there is significant development done here, and systems can respond to you. But think of, Google had made this voice call where they called up a restaurant and made a reservation through a AI assistant. That kind of technology to be accessible to everyday humans is going to be, research that's still going to evolve. Now I can kind of talk a little bit about the things that I do at Qualcomm as a Linux software engineer, my day-to-day activities. I work in the automotive software team, and I try to build automotive infotainment systems. You may ask what that is. So this is a 2010 Range Rover cockpit or car. you can see here that there is a simple display here. This is 2010, so it's pretty evolved, and this is a premium car, so it's pretty modern. If you take the Toyotas or the Hondas that I drive, it's not going to be this fancy, but this is a Range Rover, so it's going to be fancy. And look at the display; it looks pretty analog, and the simple dials out here, and a few buttons. Fast forward to 2021, and we're working on systems that look like this, with a lot more displays, a lot more digital content, fewer buttons, and easier access, a lot of touch screens. I develop on Qualcomm hardware the software that runs this infotainment system and the clusters out here. So as a Linux software engineer, what we do on a day-to-day basis is we design, develop, and debug broadly. Design new software and new software architecture, based on what the customers need and what the market is looking for. Example, autonomous driving. Develop open source or proprietary software. So the infotainment features that we develop is either on Linux or some other operating systems that support these features. And my friends at who are software engineers always say this, that there is no software that is shipped without bugs. So we get back buggy code or software issues, and we fix them. So debugging is a pretty common part of a software engineer's day-to-day activities. So in a day, our activities are classified into these three buckets of broader activities. And it's a lot of fun, but it can also get a little repetitive. I really enjoy doing all these three facets, but some people are more into designing and developing and less debugging. I really enjoy debugging because it's really crucial, where you don't have any information as to why this is failing, and you have to figure out why it's failing. So these are the different facets of what my day-to-day activities look like. And the end product that comes out after we're done working and developing the software looks something like this. Short video here. So yeah, if any of these activities I've just mentioned about my day-to-day and what computer engineering entails, and if you're interested in pursuing computer engineering as a career option, or even an option to pursue at college, I know many of you are probably in the engineering academy and may have done most of these things, but this is kind of a checklist that I thought I should probably mention, where you could, definitely your strength in maths and science is unquestioned. You're in the engineering academy, you probably have good grasp of it. First robotics, highly encourage you all to participate and take part in it. I'm not in Texas anymore, but when I was there, I was a volunteer at the first robotics event that was held at Houston. And Lego Mindstorm projects, pick up a Lego Mindstorm. These are expensive and can be very costly, but you can pick up an Arduino and Raspberry Pi, which are relatively cheap. Involves a lot more work, but is really rewarding at the end. So yeah, I think may have been a little fast. Feel free to ask as many questions, but I think that's it from me. Thank you.
Thank you so much. We're going to move on to our Q&A session now. So if you guys have any questions, feel free to put them in the chat and we will read them out loud. So just make sure to message them to me. We have gotten a few during the presentation. So we will start with, what do you enjoy about software engineering? What are some essential skills you need in order to become a good software engineer?
Sure. Yeah, that's a good one. The basic skill is to have a simple logical way to solve a problem. So as software engineers, you encounter a lot of use cases in software. They call them use cases, but think of them as simple problems. So to to be able to enjoy, to break down a problem into logical small chunks, and then try to think of a simple way. Think of programming or software engineering as writing instructions to tell a computer what to do. And if you can tell them how to do that in the most simplest fashion, you're probably going to be a good software engineer. You're going to enjoy the job. So I would say a logical thinking. And second is to be able to envision a lot of future use cases. Think of a scalable solution. When you think of Instagram or WhatsApp or any of the applications you use on your phone, it was not built for 1 billion users on day zero, or like 2 billion users. Facebook was pretty small, but the software engineers who were involved were able to think of scalable solutions that can grow as the user base grows. So to be able to envision a future use case can really help you. So be logical and think forward looking. I would say these two are the definite skills. And I definitely enjoy doing these two things at work, as I design software and develop them into implementation or solutions that go out. Definitely, logically breaking it down, simplifying it, and then making it future proof is probably something I enjoy.
Awesome. Thank you so much. The next question is, which companies are Qualcomm contracted with?
Now, I can't really answer that, but you can look up at qualcomm.com to see what companies there are. There are some public announcements. Range Rover is one of them that I just mentioned. But yeah, you can see that we're probably in a lot of the automakers, and there's a lot of information about that out there. So yeah.
Okay, got it. Why do you believe debugging is important?
Yeah, the reason I think debugging is important and it's a hard to find skill is because you're out there in the wild. Think of getting lost in you were sleeping and all of a sudden you wake up in the middle of a trail or a forest or a jungle, and you have to make your way back. And you have a few clues, and every time you find a clue, you have to build on those clues. If you make a wrong, say you went down this path and it led to a lake instead of leading you to where you have to go back to, it's difficult to it's like puzzle solving. So you go down a particular path, you end up hitting a dead wall, and then you have to trace back and then go back the other route. So it's like solving a puzzle every day. And so debugging involves a lot of thinking and a lot of puzzle solving. So that's why I really enjoy debugging. It's sometimes really hard because there's customer needs or there's pressure on you to deliver because, hey, maybe this software is causing a bug on a car somewhere down there, and people are bringing their cars into the garage, causing a lot of losses. So you may have that pressure on you. But if you enjoy the pressure, this kind of debugs can be really rewarding. Some people do like it, some people don't. But for me, debugging is enjoyable because of the ability to solve these puzzles day in and day out.
That does sound rewarding. The next question is, do you need a grad degree in order to work on hardware?
No, I think that's a good question. You don't need to have a grad degree to work on hardware, and even software for that matter. In fact, a lot of companies out here don't even need degrees. If you have a high school diploma and good understanding of math and science and have logical thinking, you can get started. But to have a deeper understanding of what you're doing, a bachelor's in computer engineering or electrical engineering helps. It helps you understand deep down. You could probably read up all this online and figure it out yourself. It'll take you more time. Just that the bachelor's degree is definitely a recommended minimum. A grad would be great. That will help you dive deep into topics and areas of research. For example, I had mentioned about quantum computing, which is something all the companies in the in the tech industry, that is the Facebook, Apple, Google, all of them are investing heavily to be able to scale for the future. They know that the computing is only going to grow, and as you folks go to college and come out, the computing is only going to be larger, and the amount of computing power that our current generation of microprocessors and computers have is not going to be sufficient. So for that, the quantum is a new scale, and to work in those areas, a grad degree or even a doctoral degree would be helpful, because that's only been done by that many people. There's so lesser people. So to work on hardware and software, I think a bachelor's is enough. But to work on the new and emerging areas, I would highly recommend grad and doctoral degrees. Yeah.
Got it. I think we'll just do one more question. When you were still in school, which was more helpful for your job, learning about theoretical and abstract ideas or more practical and real-world applications?
Yeah, that's a good question. Actually, it's a very good question. So I think a bit of both. Although I enjoyed the practical aspects of it quite a lot, and the applications of it. So think about learning physics and doing the equations. That was a lot of fun only when I understood where it's going to be applied, or think of kinematics, or any topic that is fundamental. Only when I know where it's actually being used, or where I can practically see it, would I be able to enjoy the theory that I had learned. So that's how I really enjoyed studying growing up. But having said that, I think the theoretical knowledge was really helpful, during college and also afterwards, because sometimes you think you're reading something that doesn't make too much sense, but deep down, when you come a long way, you figure out, oh, that's why I learned that. Okay, that's why I was taught this. So I definitely would say stick to your basics, and continue with the theoretical study, because that helps you transition into practical and application in the future.
Awesome. That was a really good explanation to that complicated question. Again, thank you so much to Mr. Manoj Vishwanathan for coming to speak to us today. And it was really enjoyable learning about your job at Qualcomm and your day-to-day experiences. Thank you so much.
Thank you so much, and thanks for patiently listening to me, and thanks for all the great questions. I've sent the slides out to Janvi, and please feel free to email me. I have my email address shared as well. Good luck to everybody, and stay safe.
All right, so we are going to continue on with the student body meeting. So we just have a few housekeeping items, and then you guys will be free to go. So first up is our student of the month.
So congratulations to Tien. He is not only a brilliant student inside the classroom, but is also heavily involved with extracurricular activities. He's on the varsity swim team and placed in the all-state choir during the 2020 to 2021 school year. Beyond engineering, he has many diverse interests such as music, fitness, marine archaeology, and anime. One individual described Tien as a phenomenal student and role model. Congratulations.
For volunteering and enrichment, we don't have too many updates. There is one important update for seniors, but for everybody else, still 12.5 volunteering hours will be required for this semester. And by the end of the school year, you should have those amounts. For seniors, you are only going to need 70 volunteering hours in order to get your academy distinction at graduation. And remember that instructions are posted on our Remind and on our student website for how to submit hours, both virtually and in person.
Students should also remember about the enrichment activities. So 2 enrichment activities are required each semester, and you can submit that on Schoology. For most enrichment activities, you have to submit a photo, but for student body meetings, you don't. So just make sure you have all the requirements when you're submitting.
So like I just said, for seniors, you only need 70 hours in order to receive your Yes Medal and your Academy distinction at graduation. We have updated your Yes hours in Schoology for the winter semester, so make sure you check up on that. and there's some more information there. You can check Mr. Lamb's newsletters in order to get some of those volunteering opportunities. And we also post on our website, so just check periodically to see if there are any new opportunities.
So we have calculated the house points. Last month we have Tesla, Eiffel, Curie, and Ford. And for this month we have the same order with Tesla leading at 890 points. And then Eiffel, Curie, Ford following in the same order. So guys, come on and join the SVMs. Let's earn more points. Curie House, if you're there, I'm always advocating you guys to beat Tesla. Tesla has been there, and I want to get on top of them, right?
If you're in Tesla House, keep up the good work. We got this.
And make sure to stay updated on our Instagram. We don't do any spam, so it's just informational. Mr. Lamb's newsletters have a lot of different opportunities, especially for volunteering or scholarships, updates for the academy and the school district, and it's very informative. So please make sure to look at those, and they're sent to your student email weekly.
So for the Academy officer applications, we're looking for dedicated Academy students to serve as next year's officers. Remember that you have to be in good standing in terms of grades, volunteering hours, enrichment, etc. For the first round of applications, there's going to be 5 open positions. So there's going to be the president, director of activities, communications, engagement, and then the secretary. So the instructions for this first round, if you're looking to apply for an executive position, they'll be released by spring break. And then there'll be, as always, the written application, the interview, and then the voting. For the second round of applications, the open positions will be chosen by next year's executive board. So those dates will be released whenever we have them.
Remember to stay connected. If you want to contact Mr. Lamb, his email is provided and also his school phone number. Also remember important websites. We have the Academy website and also the student website. So the student website will have any activities, socials that may be coming up. So that can help you keep track. And make sure to follow us on social media. Our Instagram and Twitter handles is @Elkins Engineers. And we also have a YouTube channel that has all these SPMs recorded. So if you want to rewatch any of the events, you can.
So help us make our events better by reviewing them and giving us comments. If you do, we appreciate your help greatly. We've been getting a lot of comments recently, and we've been taking those into account to make our events better. And I think Mr. Lamb has a little something to say, so we'll let him talk.
All right, thank you guys. All right, guys, we're almost there. We're about 3/4 away. We have 2 weeks of spring break coming up for you guys, not me. But wow, I don't think you should enjoy this. I don't think you'll ever get 2 weeks for spring break ever again. But I just want to say, especially first to my senior, make sure you get those hours in, because it is impossible for me in May to verify those hours. Remember, I don't verify those hours. It is a group of volunteer at Elkin High School. When you turn into Miss Sand, then the one who volunteer to verify those hours, and they'll send me an updated PDF every month. Then I'll put that in Schoology. However, if you really want to know, if you don't think your hour is correct, let me know, then I could check with them. Okay. Again, that's something that I do encourage you to take care of it now, especially over spring break when you have time. Because every year I'll have a handful of senior trying to rush and try to get their hours, and then they won't make it because of just the time constraint. The one thing that I do want, encourage you guys to make sure, I know, especially some of you that are going, online or back face to face, school has been very different this year. try to keep up with those grades as much as possible. That's something that the district realized that it's been difficult for everyone, and they're working really hard to figure out what we need to do to help you guys next year too. But as for Academy, as the officer is saying, we do need, for those of you that want to be in a leadership position, to step up and then apply. And then, if you don't get it, the experience itself is what the process itself is what the experience, right? So you always, want to understand that, when you apply for certain things, you might not get the first things that you apply for, or, and you might have to apply again and that will really help you in the future not be too afraid to step out your comfort zone and apply for a different position. And that will help you with applying for jobs. Sometime when you finish, when you're done with college, if you're lucky, you probably have get a job through your internship. If not, you might have to go through many, many interviews before you land that job. And, just like myself, I could tell you, in my 20-year of career, I got 3 yes, right? 3 yes. People say you got the job, but I cannot remember how many no's I have because there's just so many. So, but I keep trying, right? So that's the thing that just kind of keep in mind. Again, these officer position does take a lot of time. The one thing that I really encourage you is not just, it's not just the title. I know that our officer have to balance their school and then their responsibility as officer to organize events and reach out to speaker and doing all this. It's not easy. So make sure that you are you could balance your and have good time management when you decide to apply. Okay. But again, if you guys please reach out to me by email if you have any question, I will try to answer that as quick as I can. Just let you know I am in the middle of application process right now. So we just press the button. So most of the kids should be either accepting their academy or find out that they've been not accepted, and that's something that will keep me very busy the next few days, just kind of help them answer questions. Okay, so if I don't get back to you as soon as you think I should, just shoot me another email, then I will definitely do that. Okay, if you have any other questions, anyone? And I do appreciate for those of you that did your engineering 30-second video for me. And I had so much fun watching it, and you guys did such a great job with some of those videos. Thank you so much. All right, I'm done.
All right, thank you so much, Mr. Lam. As he said, just remember to get those volunteering hours done. And if you're interested in applying for one of those executive officer positions, just stay on the lookout. The timeline is going to be a little bit different this year than it was in the past years. So just, stay on top of things, look out for those messages and updates as we send them. So with that being said, that is going to conclude our student body meeting today. Hopefully you guys enjoyed the speaker, and we will see you guys after spring break. Bye.
Have a good spring break, guys.